right, welcome everyone. I think it's close enough there. I will go ahead and get started. Thanks for making the death march to the end of the earth, or at least that's what it felt like to me. Hopefully that's not the relative importance that Microsoft's putting on Windows Store apps. I know it's not. All right, so I'd like to start here, get you some more exercise with your arms this time, pull the audience here and get a sense of where everyone's coming from. How many of you are WPF developers? Good number of those. Silverlights? Any HTML with no XAML experience? Okay, a couple of you. So just to be clear, this session is mostly going to be about some guidance from Microsoft Patterns and Practices called Prism for Windows Runtime. You might have seen it called Kona in the abstract, and it is pretty much exclusively for the XAML way of building Windows Store apps. So if you feel like wandering off based on that, no hurt feelings here. Okay, so title is Building Windows Store Line of Business Apps. As I just mentioned, the primary focus is going to be some code that enables you to do that, which is this guidance from Microsoft Patterns and Practices called Prism for Windows Store apps. Another show of hands, how many people have some exposure to the previous Prism for WPF or Silverlight, Prism 4 or prior? Okay, fair number of hands there. So there is some, obviously with the same name, there is some shared legacy there, partly in that a good part of the team that worked on this guidance was the same team that worked on the previous guidance, including myself. I worked directly with the P&P team on both sets of guidance from the very early days of Prism 1 all the way through Prism 4, and then they brought me back in to work on this guidance as well. So you're kind of getting it firsthand from a team member here. So that's part of the reason for the shared name, but it's also a shared set of goals that this is just another XAML technology and another potential stack that you could build your business applications on, and it would help if you had some guidance around how to do that in a maintainable, loosely coupled, testable way. And that's kind of the buzz phrases that surround the overall overarching goals of Prism is to help you do that, help you build a loosely coupled, maintainable, testable application. So I won't say that too many times over in the session here, hopefully, but that's the overall context of what I'll be talking about today. And as I mentioned a moment ago, primary focus is XAML apps, but we've got this kind of three-pronged world in the Windows Store arena that you can build Windows Store apps with XAML and C# or VB, or you can build them with XAML and C++. But that's kind of a different way of going about things. Some of this could be extended into that C++ world because it's primarily XAML-based, but it would not easily extend over to the third prong, which is the HTML JavaScript way of building Windows Store apps. I've had a lot of people ask me, are they going to go put out a new version of this for the HTML JavaScript side of things? If they get enough asks for that, they probably will. So if that's something that's important to you, definitely give that feedback to them, and I'll show you where you can go to do that. So the overall agenda here, they even lost my bio slide. So there was supposed to be a bio slide in here. That's okay. A little background on myself. I'm from a company called Alliance. We're an end-to-end software development company, do architecture consulting, training, that kind of thing. I'm also a Microsoft Regional Director. If you haven't heard of that program, there's about 130 of us worldwide selected by Microsoft in given regions, as the name implies, and we work directly with the product teams and with senior management at Microsoft to give them feedback, also evangelize the products. Similar to the MVP program, just a smaller group. I'm also an MVP as well. I'm also a Pluralsight author, and relevant to this session is that I just released about a week and a half ago a 6-hour Pluralsight course that is what you're going to get in this session, expanded with a lot more detail and background. So if you want some expanded coverage there, if you have a Pluralsight subscription, go check that out. It's called, I've got a link at the end, but it's called Building Windows Store Business Applications with Prism. If you don't have a Pluralsight subscription, I've got a few cards left up here for a 1-month pass. If these run out, don't worry. Just go down to the Pluralsight booth in the expo hall, and they've got a whole ton of those to give out. So you can, go watch the course in its entirety, even if you're not a Pluralsight subscriber, and maybe that'll convince you to become one. My screen locked here. So let's see, anything else in terms of bio? That's about it. Contact information should have been on that slide for you. I will make sure that gets updated in the downloadable material so you have that contact info. But it's just brian.noyes@solliance.net is my email, or just @BrianNoyes on Twitter. Okay, so what I'm going to go through is a high-level overview of what is Prism for Windows Runtime, and then we'll get into, at a code level, how you go about using it. And so we'll start off that one of the ways we achieve maintainability and testability and those things in a Windows Store app is by leveraging the MVVM or model view model pattern. Prism doesn't dictate that you use MVVM. It does presume that you'll want some separation of concerns there, but all of the code and samples and documentation, we had to pick a way of going about that, and the way we did is the MVVM pattern, because it's the predominant UI separation pattern in XAML applications. And there's a lot of people who used previous Prism in WPF and Silverlight that we knew would probably move over to this in building their Windows Store apps. So we wanted a common migration path for that. So I'll get into how you go about structuring your app using Prism to do the MVVM pattern. Then we'll talk a little bit about navigation and state management. Those are two of the bigger challenges when you dive into Windows Store apps, that you got to get used to this new way of structuring your app and how you move from page to page, and also the fact that there's an application lifecycle you have to comply with, that your app can be suspended and terminated at any time, and when the user brings it back up, it should look just like it did before. And that means all the transient state in your application you've got to do something with. And if you're doing the MVVM pattern, that transient state will generally be down inside your view models. So Prism has some support to make it really easy to automatically persist that state and have it restored for you. So we'll look at that as well. And then at the end, we'll look at validation as something that's kind of completely lacking in the WinRT platform right now. All the SDK samples and all the sample apps you see out there, it's mostly about content consumption. It's more consumer focused, and it's more about putting data on the screen, not creating data through the screen. But as soon as you get into the business arena, validation obviously becomes important. When they start typing data into inputs in the screen, you want to make sure it's correct data. And unfortunately, unlike WPF and Silverlight that have good built-in capabilities through their bindings and stuff, there's not built-in support for that. Prism helps you out there, and we'll take a look at that at the end. All right, so overall business context that Prism is targeting is there's a couple different kinds of business apps that you might want to build. One is the concept of a business to consumer, and certainly with sort of the consumer focus of WinRT and Windows 8 at the current time, that's the more common form of business app being built today for Windows Store apps, is that if it's going to go in the store, it's generally going to be people outside your organization that you're trying to get that app out to. Now, part of the terminology to get used to here is that Microsoft, the preferred terminology there is to call these things Windows Store apps, even if you intend to build it as a business app and sideload it, which is a capability to deploy it directly to the machine without going into the Windows Store. It's still a Windows Store app. You're going to say File, New Project. You're going to pick the Windows Store category in Visual Studio. That's how you're going to go about building it, even if you never intend to put it in the Windows Store app. So just keep that in mind as I go on. I kind of intermix the terms here, WinRT and Windows Store app. They mean the same thing. So a lot of apps can be business to consumer. This could be, your United Airline app to go book your tickets and check your flight status, that kind of thing. They could be product catalogs to go purchase things, like Newegg has an app out there to go buy things from the Newegg store and things like that. The other kind, in the title of this course is line of business. And the main distinction here, from our perspective on the Prism team, there was really no difference here in terms of how you would go about building your application. It's more who's going to use the application and how you would get it on the device. As I just mentioned, if it's a line of business app, most people consider when you say line of business, it means it's someone's job to use that application. That someone is generally an employee of your company, or maybe a consultant that works with your company in an employee type of role. And it may be their entire job to sit there 8 hours a day, 5 days a week working on that single app. Or it may be just an integral part of their job function. They may be some warehouse manager that uses an inventory app for this and a shipping app for that and so on. But it's, an inherent part of their job is to use the app to get their job done. And that's one of the things that distinguishes a line of business app versus a business to consumer. So Prism really addresses all of these. One of the negative pieces of feedback we get is the scenario we picked for the big sample app I'll be showing is the business to consumer. So even though the primary target audience is for line of business developers, we picked the other category just because it's more approachable and easy to understand as a sample application. So Prism for Windows Runtime, actually let me go ahead and switch over here to my machine if I can get it unlocked. Lots of screensavers of all kinds here. Okay, so the place you're going to go to get this, if you just remember Prism Windows Runtime.codeplex.com is the home for this. If you see here on the page, there's some announcement blog posts. It did just recently fully released. It's been in development a long time. As I mentioned in the abstract, you might have seen the term Kona. So Kona was our code name in development. And then we decided to go ahead because of the shared heritage there and call it Prism for Windows Runtime. If you follow the link here for the code, it's going to take you over to the Windows SDK samples. So this actually ships as part of the Windows SDK samples now, at least most of the code. And the main sample application I'll be showing and the reusable libraries are in that download as code. It's also available if you just want to treat it as a third-party library that you're going to pull into your apps. You can pull it down via NuGet. So you can follow these links to get to the downloadable NuGet packages, or you can just go into Visual Studio, right-click, manage NuGet packages, and search on Prism Windows or Prism Store apps and Prism PubSub events. And I'll explain what those are as we go here. Separate link for the docs, which takes you over to MSDN, is where the docs live. And then the downloads over here still downloads something separate. So it's kind of weird fragmented world because of the way it ships. Part of it ships as part of the SDK. You still want to get the downloads here because these are the quick starts. So the main sample app, because it's kind of end-to-end and went through the full certification process as if it was going to go in the Windows Store, that is qualified to be part of the Windows SDK samples. Our quick starts are more quick and dirty, show you how to use some of the features of Prism. They don't quite meet the quality bar to be in the Windows SDK, so we keep those out here on CodePlex, but you'll want to pull those down as well, and I'll be showing some of those in the demos here. So let me switch back here. Okay, so what's in the box, if you will, with Prism? First off, there's this end-to-end sample app that I've been mentioning. It's called AdventureWorks Shopper. You can guess what the underlying data source is there. But it's a product catalog kind of shopping experience with a checkout and some data input scenarios with addresses and payment info and that kind of stuff to demonstrate some of the validation scenarios. And I'll be demoing that for you here shortly. There's the quick starts I just mentioned. There's really 4 of those. There's 2 variants of a Hello World quick start, one with and one without a dependency injection container. So one of the decisions we made in the design is we didn't want to force people to adopt a dependency injection container. Previous Prism 4, it was kind of a preformed assumption that you would use a dependency injection container of some sort, either Unity or MEF, were supported out of the box, and you could extend it to any dependency injection container. We found in people adopting Prism 4 that was a big conceptual hurdle for a lot of people who had never used a container and had no desire to do so. So we made a conscious decision here to make sure that you can use all the capabilities of this Prism for Windows Runtime without adopting a container. So the one Hello World that I'll show today is not using a container. The other shows it with a container. And if you go into the code of the AdventureWorks Shopper, it's actually using the Unity container. But it's got hooks there that you can plug in whatever container you want for dependency injection. The validation one I'll be showing today, it just kind of drills down on just those validation capabilities, as I mentioned, are a pure add on top of the WinRT capabilities. And then there's a separate one for the PubSub events, which is purely separable itself, and I'll talk a little bit more about that in a moment. The documentation is pretty good. I wouldn't say it's great for reading end-to-end, in book style. It's not tutorial style. It's a little bit more referencey material, but there's some real good nuggets in there because in going through this, we were kind of in the discovery process ourselves as a team in that all of the WinRT platform guidance and samples and everything are all very page-centric. You put everything in the code behind your page. But as I said, one of our goals up front was to do MVVM from the start. And you find very quickly there's some disconnects there that as soon as you want the focal point to be your view model, all the APIs that you want to access are out there in the page, and they're unmanaged WinRT APIs that you're calling into that you don't want to take direct dependencies on in your view models when you're doing MVVM. So there were a lot of design decisions, and we tried to capture those in the docs of why did we do it this way, what were the other considerations that we looked at, and so on. So there's some real good learning in the documentation in that form. The 2 most important things that are in Prism probably for you moving forward and using this guidance to build out your own business apps are the reusable class libraries. So really the way we approach this, good frameworks are not built, they're grown. And that's kind of how we approach this, is we built the AdventureWorks Shopper application, and as we built it, we tried to tease out any reusable code that we could into these libraries. So it's not even, I wouldn't even call it a framework so much as libraries. There's subtle distinctions there, but it's libraries that help you do all the stuff shown on the screen. So there's base classes for views, view models, and your application class to help you do MVVM structuring, which I'll demo shortly. There's navigation support to tie into the navigation APIs. I'm not going to go as deep into that in this session. I will demo it a little bit, but I've got a whole session dedicated to navigation tomorrow. So I'll go a little bit more deeper into the underlying navigation of WinRT itself tomorrow and the application lifecycle, and then I'll briefly show the Prism stuff again tomorrow in that session as well. Commands are part of MVVM communication patterns. To talk from a view down into a view model is often done with commands, so we have support for that. And really, for those that raise their hand of having exposure to Prism 4 in here, this was just a direct port of the delegate command from Prism 4 and just making it compatible with the WinRT APIs. The validation, like I said, is a pure add, and I'll focus on that at the end. We also have some wrappers around the way you go about doing the search and settings charms in WinRT, as well as how to do flyout panels. And most of those are very thin wrappers. A lot of this was, the goal was just to, along the lines of testability and keeping your view model code testable, it's that you don't want to take direct dependencies on unmanaged WinRT APIs in those view models, because then whatever method is touching those APIs is not really unit testable. So a lot of these are just thin wrappers, putting an interface boundary on top of the underlying WinRT APIs so that you can inject those into your view model and just call through those abstractions. The pub/sub events is factored out into its own class library because that one is actually a portable class library. If you're familiar with those kind of projects, you can have multiple platform targets with those. So this was actually a realization of a goal I had back in Prism 1. Originally in Prism 1, we wrote it just for WPF, and then we extended it to Silverlight. And in doing the pub/sub events that were in previous Prism, they were taking direct dependencies on the dispatcher of each of those technologies, which is a different dispatcher and is really a thin wrapper around something called a synchronization context under the covers. But synchronization contexts are common across all the .NET platforms. So in here, basically, we refactored all that, made it so it only depends on synchronization context for thread dispatching, and put it into a portable class library, so it now works with any .NET 4, Silverlight 4 or later, Windows Phone 7.1 or later, or WinRT application. And pub/sub events are basically a loosely coupled communication pattern, so that you can have publishers and subscribers that don't have any direct dependencies on each other. Main place it really comes in with MVVM is so that view models can talk to other view models without having coupling between them. All right, so let's get into a demo quickly of the Adventure Workshopper I keep talking about. And let's just see what this thing looks like at a functionality level. I'm not going to drill into the code of this thing because since it is a full end-to-end, realistic application, there's a lot of code there. So this is more of a, take it home for homework and drill into some of these things. This is just to get you familiar with what's in there so that you can drill down and see how it does it. But I'll drill into a couple of the features in a more simple example in separate demos. So this thing fires up. You see a splash screen, a little spinny thing there because it's doing asynchronous service calls to a backend web API. We used ASP.NET Web API for the backing services. They're all part of the project that you pull down in that source code. You can see it's a product shopping catalog type of thing. It demonstrates navigation, multi-level hierarchical navigation here that we can drill down to what are called section groupings. If we go to something a little further over here like bikes, has multiple sections, so it's actually categories and subcategories here. So we've got mountain bikes and road bikes. We can drill down another level, and then we see the individual items within that category. And then we can drill down to a single item, and we see product detail type information for it. You can also, another good way for an app like this to get to the data is to search. So we show the integration with the search charm here. Notice that we have our own icon to invoke it because it's a primary form of use of the application, but we don't embed the search in our application. If you follow the Windows Store guidelines, you should use the search charm to the extent possible. Unless your app is all about search, like the Bing app, then it can put the search box there right in the app. But if your app if search is a subsidiary function of your app, then you should integrate with the search charm, which means the OS presents the UI, and you basically get an event, a callback from the OS when the search occurs. So I can put in a search term here like lock, and you can see the search experience happens within the app, and it shows up in the list of apps down here that supports search. And if you're not familiar, that also means they can even launch your app. If it's not the one on screen, they can select it, and it causes a launch of your app, and then the search comes into your app when they execute it. When you're down at a product detail level, you can see we have an Add to Cart button up here and a little cart icon in the upper right, so we can add things to our cart. That icon is not really just an icon. It's actually a whole separate view and view model talking to services and so on. So it actually, the entire UI of that view is just a button which seems like a little bit of overkill, but it's more because behind that button is a fair amount of logic of when do I talk to a service, what state am I maintaining of the count of items, am I logged in, is this transient state on the client side, or have I logged in and am I persisting it to the server side? So there's a lot that goes on behind that button. And so it warranted breaking out into a separate view model itself, if for no other reason than to show some compositional scenarios with MVVM. Then we can go and check out, and we have it'll list all the things here. We can select the items here, and you see the use of app bars here for managing that cart, and we show the concept of flyouts here. So this is another UI paradigm in modern applications that you can have these light dismissible flyouts. If you click anywhere else or touch anywhere else on the screen, it just goes away, gets out of your way. You don't have to cancel out of it. But while it's on the screen, it's fully interactive, and you can show a rich interaction with some item on the screen there. Then if we go to checkout here, we have a login experience with the back end. At this point, we decide that you need to log in to go any further. So we've got a stock account there. Notice the Save Credentials box here. It demonstrates the use of something called the Password Vault, part of the WinRT APIs to securely store credentials. And when you store those credentials in there, they're actually part of your profile. If you're logged in with a Microsoft account, that will automatically roam to any other Windows 8 machine that you log in with the same Microsoft account. So if I run this app on this machine, check that box, go jump to my Surface, fire up the app, then I'm already logged in on that box. I won't check that for now. And then we get to some of these data entry scenarios. So we've got to put in some information for shipping here. Now, one of the things we did with the validation is we said we don't want to bug the user until they've actually done something wrong. A lot of times you'll see forms like this that they show up and everything's red because it's all required information, but they haven't had a chance to fix that yet. Don't annoy the user until they've done something wrong. So here, once I start putting stuff in, if I get it in an invalid state, now you see our basic validation experience there as we red box the control, similar to what WPF and Silverlight do by default, and we have a text block down there to display the error associated with that. And I'll show you the infrastructure later in the talk that supports that. So let me just quickly put in some stuff here that looks like the information it wants. Don't need that. We do need a state, so let me just put one here so I can demonstrate something else about the validation there. If I put in an invalid zip code there, client side doesn't know enough information to validate that. A lot of times there are things you got to go to the back end and do a lookup on. So we wanted to support that as well, and we do. I'll show once I try to submit here. So we'll just put in some numbers that look like a phone number. We can check this box so I don't have to fill in all those. And then we can put in some kind of card-looking number over here. I think this is validating that it looks like a date and year and another kind of phone number-y thing. See if that passes. Okay, so then when we submit, notice we get an error message there. The field that's in error is off screen, so we wanted to show a kind of a validation summary type approach over at the submit button that tells you where to go. And now we go back over and we can see it actually made a round trip to the server, did a lookup on the server of what are valid zip codes for Virginia, said that's not one of them, and it returned some structure information to the client side that it could reaffiliate through the same validation mechanism with that field and display it in the same way. So it's transparent to the user where the validation happens. It's just a matter of whether they get immediate feedback or not. And if you really wanted to be aggressive about it, you could do something like RIA Services does and go trigger that asynchronous call to the server, in an AJAX kind of way, do it in the background and push that information into the control even before they submit. All right, so we'll just correct that to a valid zip code for Virginia and submit again. And then we end up at a summary page. There's a little bit more, of these flyouts here that you can play with, but ultimately you get to the submit phase and it's just going to go ahead and re-authenticate was a decision they made, and then we get an order confirmation. The other thing that's kind of shown in this application is settings charm. As you can see, there's discrete settings associated with the app. If you want to pre-enter shipping, billing addresses, things like that, you can get to those, and this shows doing a whole page navigation within the app when you select a setting. We also have ones like the logout here that show doing a flyout settings panel. So all those things are demonstrated in this app and have supporting code. And most of the code for doing all those things are factored out into these reusable libraries so you can do it in your own apps. All right, so let me switch back to the slides for a moment. So to go ahead and start building out an application like this on your own and following the MVVM pattern, there's a couple of things you're going to use in the reusable libraries there. First thing you're going to do is you're going to swap out your application base class. So if you've done a Windows Store app, you go file new project, Windows Store app, and pick one of the templates there, the grid template or the split template in particular. You go into the application code behind, and there's a whole bunch of boilerplate code with if terminated this, suspending event handlers here, and it's a bunch of kind of grungy code that it's scary to wade into and figure out where do I put what, where do I need to restore state, where do I want to do things. So we kind of factored all that down into a base class called MVVM app base that takes care of doing all that boilerplate stuff, and then it exposes some overridable methods for discrete phases in the lifecycle that you may want to override or do application-specific stuff. So basically, you'll swap that thing out. It also does some initialization of some of the services that Prism sets up for wrapping navigation and the application state management that I'll be showing in a later demo. Then there's a visual state aware page. If you've been exposed to the layout aware page, that's part of the standard code that Visual Studio injects in those projects. Think of this as an evolved layout aware page that knows about MVVM. So it sets up the right patterns to do the state management through a thing called a session state service, and also has some of the same stuff that's in layout aware page for managing visual state, thus the name. Then you have a view model base class, and this sets up some of the infrastructure for, obviously it's the base class you'll put on your view model classes, but it has some stuff to let your view model participate in the navigation and the state management aspects that Prism is helping you out with as well. Because generally in MVVM, the place that your navigation logic should reside is going to be in your view models, and the place that all your state management happens is in your view models as well. Because my elevator pitch about MVVM is that the view model offers up offers up data to the view in the way the view wants to see it. The big part of the view model's job is to expose properties for the view to data bind to. So it's got to get the data into those properties. It's got to decide when to persist the data from those properties. So the view model is really the focal point for state management in your MVVM applications. But you can also have things behind the view model, such as repositories or client-side services, that has state that needs to be managed as well. We chose to implement a common pattern in MVVM. It's called a view model locator. Ultimately, when you do MVVM, you got to create a view model, and tie them together by setting the data context of the view to the view model instance. And there's different ways of going about that, but the view model locator is kind of a dynamic way that gets you centralized control of how that happens. So we went ahead and implemented a view model locator in Prism for Windows Runtime, and it automates that whole process of hooking up your views and view models. It is convention-based itself, and I'll show that in the demo, that it presumes you're going to put your views in a particular place and name them in a particular way relative to your view models, similar to the way if anyone's had exposure to MVC, ASP.NET MVC, everything's very convention-based there of how it locates your controller based on the URL is based on a naming convention there for your controllers. So we followed some of those same conventions, but everything's overridable. You don't like the conventions we have, you just override a method and take control of it yourself. So let's see what all this stuff looks like. For time's sake, I'm not going to build up the code from scratch here. I'm going to try to cover more material just by walking through it as if I was writing it, so I don't fumble around on the keyboard here. So I'm going to use the Hello World quick start that comes with the Prism code. And like I said, this you would get off of the Codeplex site as opposed to the SDK download site. And as I said, the starting point would be that you would drop in, you would file new project, and I would generally start with a blank application. If you start with the split or grid apps, those are a good starting point to learn about the layout schemes in Windows Store apps, but then you got to tear out all their sample data source and all their specific things that they're doing as sample code. So the blank app is generally a better starting point here. Then you're going to need to pull in Prism. As I said, you could go right-click, manage NuGet, or somewhere down here, manage NuGet packages, and search on prism.storeapps. And you can see the two there are PubSub events and store apps are the ones you'd want to search on. I got to be in the online section there. But those would come up and you can pull them in binary form. When you're first getting started with this, though, I recommend you pull in the code. The code's available. It's all open source. If you want to take it, modify it, rename everything, redistribute it, that's all completely legal based on the open source license. It's not open source in the sense that they don't take, get pull requests at this point. They're not set up for that, but they are very open to feedback. If you have feedback, you can give that to them. There's a discussion forum on the CodePlex site that you can give them feedback and try to steer what they put into subsequent versions. So when you're getting started, I always recommend just pull the projects directly into your solution so you can step the bug into them, really understand what they're doing under the covers, and then set a reference to it, obviously, from the app you're going to use it from. So the starting point, as I mentioned, would be to go to your app class, and if you had just done file new project, there would be a bunch of boilerplate code, as I said, in here, and the base class would be application here. So you would swap that out, change it to this MVVM app base, and strip out all that boiler code. Strip it down to just the constructor with the initialized component call. And you would have to strip out in the standard code, there's a suspending event handler in there you would strip out as well, because that's handled down in the base class for you. Then you have one override that you have to do because it's an abstract method called onLaunch application. Now there's a separate onLaunched that's part of the application base class. Don't override that one or you short circuit some of the stuff that is encapsulated down inside of Prism. So it's probably poor naming there to have them so similar, but you want the onLaunch application, and you can't get it wrong because if you just try to compile without it, it's going to complain because it's an abstract method. The main thing you're going to have to do there at a minimum is you got to show your first page. Everything's a page-based navigation system at a top level in a Windows Store app. And the way we do this is we have this thing called a navigation service that's a wrapper around the WinRT frame class that does the navigation. And I'll talk a little bit more about that later in the session. But what you've got here is this is where some of the conventions start kicking in, is most of the navigation calls other than this one in your app are probably going to happen down inside of view models. View models should not be coupled to views in any way, either by type or by instance. So we didn't want these navigate calls. The way the frame does it is you give it a type of a page, it will create the instance of the page and it will navigate to it. We didn't really want to do that from a view model because then you're coupling your view models to particular view types. It's one of the things you want to avoid in MVVM. So what we went with here is a page token, we call it, is the parameter name. And you can see we just call it main here, but we're doing similar to how MVC finds its controllers. Is by default, we're just going to tack page on the end of that, and we're going to look in a particular place. Specifically, we expect you to have a views subfolder and corresponding namespace, and that's where we're going to look for that type, create the instance of it, and navigate to it. If you don't like that convention, you want to put it in a totally separate assembly, which if you look in the AdventureWorks shopper, I meant to show the solution structure there. But we've got all the view models, client-side services, repositories, all that stuff factored out to a separate class library for testing reasons. So if you want to do that, you just override some of these conventions. Specifically, there's a override in here for get page name, or get page type rather. So it takes in the token that those navigate calls take in, and it's up to you to come up with the type based on whatever convention or scheme you want there. You want some big giant switch case with all the view types in your application, party on. I wouldn't recommend that. Okay, so that's the basics of what you would put in your application class. There's some other stuff down below hidden I'll come to, but then you got to start building out the views and view models in your app. So you would have your main page here, again just tacking page onto whatever you're using as your token here, and then you would have a corresponding view model for it. The page itself. Before I forget though, I mentioned swapping out the base class here on the app. If you do it here, you also have to do it in the XAML. So in the XAML root element, you have to do it here and here as well. Then similarly on the page, you drop into the page code behind and you change out. If you've created this by saying add new item and you pick the basic page as a good template that sets up the header and the back button for you, that's going to populate the common folder with what's called layout aware page, suspension manager, a bunch of helper classes there. You can just leave them there. That's what I generally do so it doesn't keep reprompting me, but you're not going to use those because Prism has its own variants of those. So you'll change out from layout aware page or just page if you create a blank page and put visual state aware page. And then again, the default templates have a whole bunch of code in the code behind there. You strip it all out and you get it down to this is your kind of MVVM nirvana here is no code in the code behind of your views, just the constructor with the initialized component call. If you change out the base class here, unfortunately, you also got to drop into the XAML and change it on the root elements here as well. Starting to sound kind of tedious. Well, the good news is you don't have to do all that manually. Unfortunately, we didn't get to it as part of the Prism team, but one of the Prism team members, David Britch, who wrote all the documentation for the team, a consultant over in UK. Boy, I didn't install them on here. Or did I wait? Let's see. C#. Where are my categories? Yes, I did. Okay. He created, it's a physics you can download. If you go to my blog at briannoyes.net is my blog. I have a recent blog post on this that point to where these are out on the Visual Studio Gallery. But you can just pull down a physics, install it on your machine, and you will have project item templates and add new item templates for views, view models, and the projects here. So if I just say add new project, MVVM app, Prism here, it's going to set up all the structure I'm showing you in the Hello World as a starting point with just empty views. And then you can just right-click, add view, right-click, add view model to those subfolders, and it's much more quick, and you don't have to do all this manual switching out of base classes and so on. Okay, so let me just go back here. So again, you would make sure that your base class on your pages is Visual State Aware Page, and on your view model, you would use the view model base class. And then you would start doing standard MVVM stuff there. You would expose properties from your view, or from your view model that your view is going to bind to, put bindings in the view that point to those properties. Now you got to get those two tied together somehow. And the way you can tie them together in Prism is to use that view model locator I talked about. So what that looks like in code is a simple attached property that you can put on your view. It's called an attached property or a behavior here. Basically, you're going to set this attached property on your root element of your view, whether it's a page or a user control. And by virtue of that being set to true, it kicks in some logic that basically says, go find a corresponding view model for this page. It can figure out the page type that's being loaded. It's being newed up. It basically infers a view model type and namespace for the view model. And again, by convention, it's going to look in a peer subdirectory called view models and child namespace specifically. So it really just does a string replace on the namespace and say, take out views and put view models in, and then tack view model onto the end of whatever the page type was. So you can see here for main page, it's going to be main page view model. For user input page, it's going to be user input page view model in those corresponding directories. Again, you don't like that particular organization or naming convention, there's overrides for all of this in the view model locator. If you want to have your own naming convention, you want to put them in different places, you want to construct it yourself because you have dependencies to inject, you can do all of that stuff. And in fact, if I go back up to the app class, we show some of that here. We have another override called onInitialize. This is intended to be your kind of one-stop shopping in your app class to set up all your app dependencies, initialize singletons and client-side services and repositories, anything that need to be newed up kind of centrally in the application. And here's an example of how you can take over the process of newing up your view models and not only have control of what type it is and where it's coming from, but even new it up yourself, as we have a register method on the view model locator where you can say, if this is the view type being loaded, then here's my factory method through a Lambda expression where I new up my own view model, pass it whatever parameters it needs because it depends on those things, and then it can be off and running from there. So basically delegate the call into your register method as a factory to new up the view model for a corresponding view. Now this is the non-dependency or non-container-based dependency injection way. It's called manual dependency injection. If you go look at the other Hello World or at the initialize method in the AdventureWorks Shopper application, you'll see a whole bunch of register calls against the Unity container, setting up mappings of interface types to corresponding service types, and then there's no view model initialization there because those all happen through the container. I won't go into that in detail here for time. So that sets up the basic MVVM structuring. Change out your app base class, change out your view base classes, or just use those project item templates. Define your view models, expose properties and bind to them, and then tie together your view and view model through the view model locator. You don't have to use this view model locator. If you like putting a XAML statement in there that says, page.dataContext and news up an instance of your view model that way, that obviously still works. If you want to do it from the code behind of the view, if you want to do it some view model first way with using data templates in a data bound scenario, if you've been exposed to MVVM, there's a lot of other ways to go about this. This is just a convenient, standardized, convention-based way to make it automatic for you. Okay, with that, let me switch back to the slides for a moment. cover a few more concepts before the next demo. So when it comes to navigation, as I said, the first premise here is that you're going to be using MVVM. So you're going to have a page that's going to be navigated to, or that's, let's say, a page that's currently on the screen. And that's going to have a corresponding view model. If you're doing MVVM, again, the logic that's probably going to command and decide when it's time to navigate to another page is in something like a command handler inside of your view model logic, and it needs to be able to control the navigation. But the place the navigation is really centralized in the WinRT APIs is this frame class, which is a UI element itself. It actually derives from content control. So you really don't want to have a direct dependency on the frame class down inside your view model to make those calls. So what Prism does to make it more abstracted out and testable is it wraps the frame class in a service, a client-side service. And it's called Frame Navigation Service, and it's interface-based. So in your view models, if you want to control navigation, you just take a dependency on this iNavigation service. And that was what I was showing in the code. Part of that register method for the view models was so that we could pass the navigation service that's created as a singleton up in the app base class. We want to pass that down into our view model so that they can control navigation. So basically when a view model decides it's time to navigate because the user pokes something on the screen, it just makes a navigate call similar to the one I showed up at an app level, navigate with a page token and optionally a parameter, and it triggers the navigation system. Now, ultimately what's going to happen is you're going to navigate to another page that probably has its own view model, but before you get there, when you navigate away from a page, by default, pages are released in WinRT, similar to if you're familiar with the page lifecycle for a web page in ASP.NET. The whole page and all of its subsidiary objects is newed up when the request comes in, and when the request goes out the door, it can all be garbage collected. The default in WinRT is the same thing here. So as soon as you've navigated away from that page that's currently on screen, it's going to potentially be garbage collected along with all of its objects, including the view model. But the view model may have state it's managing, it may need to contact a backend, it may need to unwire events and things like that. So we wanted to give an opportunity for that view model to do its own cleanup. So part of what the Frame Navigation Service does before it actually triggers the navigation is calls back to the same view model and says, hey, you're being navigated away from. And the reason we do that is obviously if it's triggering the navigation, it probably knows that it's being left. But you can have other views when you have composite scenarios. Think of that shopping cart in the upper right corner of the AdventureWorks shopper. I said that's a whole separate view and view model, but you saw when I clicked on it, it causes navigation that makes the current page go away. So once you start getting into compositing scenarios with MVVM, the view model that's commanding the navigation may not be the one that's being navigated away from. So we want to accommodate that here, and the Frame Navigation Service will call back to the view model, tell it, hey, you're about to be left, do whatever cleanup you need to do. And then it's actually the, whoops, too many clicks there, but it's actually the frame itself down inside of WinRT that talks directly to the page through unmanaged APIs, news it up, and basically loads it as its content within the frame. And then basically so that the view model can participate in that process, then the Frame Navigation Service will kick in, and it will make a call to the new view model that's just been loaded up. It's called onNavigated2, and it gives it an opportunity to do any initialization. So that's your equivalent to an onloaded event in your view model. So that's all just wrapped up in this Frame Navigation Service for you. Now, another thing that gets tied in with navigation is the application lifecycle WinRT events. And I alluded to this earlier, but it's kind of the bane of your existence as Windows Store apps. There's guidance there that says if your app, well, I'll just talk about it as I draw up the diagram here. So you've got a set of application lifecycle states that your app's going to go through. Obviously, it's got to start life somewhere, and that life is no life at all. It's been installed on the machine, and it's in a not running state. You actually end up in the not running state after a machine restart as well. So basically, you're not running, and then user clicks on a live tile or something on the screen and gets it running there, and it's fully up and running, just like any other XAML app you've ever built. That it's got threads, it's got memory, it's got a stack, it's got a heap, and all that kind of stuff. Then the user gets distracted, and they go to check their Twitter feed with another Windows Store app. And so they swipe away from it on a touch-based device, or they window key tab away from it, or they hit the window key and go to the start screen, or they go to the desktop. Anything that takes your Windows Store app off screen means your app goes and suspends. There's a few second delay there, but it's basically going to suspend, and there's an event that fires into your app at that point. Then if they come back fairly quickly to your app, it's just going to resume. While it's in a suspended state, it's got no execution. It's still sitting there in memory. All your objects, your object graphs, your views, your view models, the data that the user has typed into a field, that's all just data in memory. And so that's all still there sitting in memory while you're suspended. As soon as they resume, it just gets threads again and starts executing. But in that process, nothing actually happens in the app when you start running again. There's no event that fires. Take a drink here. There's no event that fires that says, hey, this app is now running again. So you have to do what you need to do in the suspended, and it gets more complicated as you get into the other application states. Obviously, the user can fully close the application at any time. On a touch-based device, if you don't know, it's a swipe from the top to the bottom of the screen for all you new Surface people out there with your handy new devices. Or obviously, Alt F4 still works as a keystroke to close the application. It will actually transition. It will follow the same path that it first suspends, and then it actually closes and erases the memory, basically frees up the memory, and goes into a closed by user state. And then if the user launches again from there, there's a flag that comes into your application launch handler that tells you what state it's coming out of as it's launching. So really your only indication when you start running and your app initialization code gets called is this flag that tells you what was its last state the last time it ran. Now where things get complicated is termination. So termination becomes this thing you have to constantly think about in terms of designing a compliant Windows Store application, because the design guidelines say that if your app gets terminated, and the reason this happens generally is, they swipe away from your app and they fire up news and they fire up videos and they fire up music and they fire up all their favorite apps, and you're running low on memory on the machine. So the OS steps in and says, well, they haven't touched that one in a while. It's been suspended for a while, so it will just terminate it. And it's pretty much literally just freeing up the memory. There's no events that happen. There's no execution that happens in your app. There's no opportunity to react to the fact that you're being terminated. So it means that any time your app is suspended, you have to presume the worst and presume that you're going to be terminated. Because the design guidelines are that if your app is terminated, when the user launches it again, it should be transparent to them whether it's coming back from termination or whether they just reactivated it from suspension. So even though it's completely gone away as far as an execution cycle, no memory, no threads, no nothing, you got to start back up, and it's got to be right back on the same screen there we're on. If they've filled in 20 fields on the screen, those should all be filled in. If they've got a scroll position, it should be at that scroll position, and so on. So that's where life gets complicated in these Windows Store apps, is it's up to you to do all that, to figure out what all those pieces of transient state are, and to make sure they get restored on termination so the user sees the exact same thing they saw when they last left it. And that's where Prism kind of steps in, and if you're maintaining all your state for those things, back in your view models and your client-side services, we've got some infrastructure to make that really easy for you. So when the user launches again, they should see the screen exactly like they left it, and it should be, the user should have no idea of termination, basically. So the way Prism helps you out here, this just restates what I said a moment ago. In MVVM world, all of that state, if you're doing things right, is in properties on your view models or back in objects within your client-side services and repositories. So that's the thing you're going to want to be persisting your data from. So for the view model properties, what we've got in Prism is a simple attribute. You can just slap this restorable state attribute on your properties. They can be simple properties like strings and integers, or they can be whole complex object graphs. There is one extra step if it's a complex object graph, is up in your application class, you have to register that type. So that basically what's going to happen under the covers here is it's going to serialize that object on suspension. So again, assumes the worst, that you might end up terminated and then resuming. So every time it suspends, it's going to serialize the data in these things out to disk. And to do that, it's got to have some type information for it. So I'll show it in the demo briefly what you have to do there. For the stuff that's back further behind your view models and client-side services or repositories, we've got a session state service that you can take a dependency on. It's basically a glorified dictionary, but it's an auto-persisting dictionary. So again, when you suspend, this dictionary will persist to disk. If it sees that the app is being launched from termination, and that this, well, actually for that, basically just that the app is being launched from termination, it will read back in that data, repopulate that dictionary, and now when your code starts reading and writing from it, it's just like it was when you left it. but it is smart enough to know if you launch and it's not terminated, then it doesn't load that data because you have a fresh launch from the user. All right, so what this stuff looks like in code. Let's go back here, get through all our lock screens. I need to change my timeouts here. Sorry about that. Okay, so if I run this hello world, we'll see a couple of examples of the state that we're trying to maintain here. First off, the main page that it lands on is just doing some simple data binding. If you looked at that view model I briefly went through, there was a property for a collection of strings that's being bound to a list view here. So just some basic data binding setup in MVVM there. Navigation, we've got a button hooked up with a command. I'll show the code in a moment. And that causes navigation to a separate page. And this page has some transient state. Okay, so 2 input fields from a user, but again, keep in mind this could be a scroll bar, it could be a selection within the list view. Any of those things are transient state that you should really retain for your user. Or a discussion I had with another MVP, Daryl Miller, the other day, is he was asking some of the why did we do certain things with our web APIs on the client side? And the answer was basically we've got HTTP client objects that make the service calls, and it would be more efficient to keep those things around because if there's headers and cookies and stuff that were in those from round trips to web APIs, then you wouldn't have to keep recreating them and repopulating them. But because of this whole termination thing, that's just an object with stuff in memory. If the memory goes away, then all that stuff goes away anyway. So we have some explicit code managing our HTTP clients and reading and writing cookies out of them every time we go to make a service call for that reason. So it can be, several layers back. But in this case, we've just got some transient data here from the user. So where this comes in is if I go back to Visual Studio, and if you don't see this toolbar, it's called the debug location toolbar you can bring up. It's got this button where you can, work with and debug this application lifecycle. Kind of bad labeling here, but suspend and shut down really means terminate. So if I terminate this app right now, and I go ahead and launch it again, you'll see that we land on the correct page and all that transient data is still there. And that's because we've got this Prism support helping us out. Apologize for the cough here. So what we've got, if I don't lose my voice, you can see one of those fields was bound to this string property and just has this restorable state attribute on it. So that's all you need to do. If it were a complex object, say a customer or product or something like that, the one extra step we'd need to do is go out here to our app class, stop debugging, and do one other override, which is register, on register, known types for serialization. And basically you would go into this thing called a session state service and make a register known type call. If anyone's had any exposure to WCF and data contract serializers, that's why we're doing this. If you go dive into the standard boilerplate code that gets injected in a Windows Store app, up here in your common folder, there will be this thing called the suspension manager. And the suspension manager uses the data contract serializer from WCF just as a serialization engine to persist those object graphs. So we did the same thing in our session state service. It's really just a glorified wrapper around the same code that's in the suspension manager to read and write the stuff from disk as your app starts up and shuts down. But to do that, it has to know about complex types that you're going to read and write through it. Is it possible to change the serializer? Well, you've got the source code. So yeah, I mean, if you wanted to change it, for example, if you wanted to change it to JSON.NET, might be a reasonable thing you wanted to change it to make those things more compact. And JSON.NET has some nice extensibility hooks of its own as well. So yeah, you would go down into the Prism implementation of the session state service. Either just copy the code and create an alternate one, or just modify the code. But no, we don't have any prefab extensibility points there for that. Okay, so that's if you have complex objects as your properties. But in this particular demo, we've just got simple things, strings basically. So we've got one of those strings was bound to this, And so we put this restorable state. To show the other form of persistence there, you can see this property that we're bound to is really reaching down into a client-side repository and reading and writing data out of that. Sorry for the obnoxious cough here. If we go look at that repository, which is down here, the idea is this thing's going to be retaining, to hold on to that data. Think of it as a list of customers that you retrieve through a service that you don't want to keep making the service call to go get that list of customers again. As a result, you're retaining things in memory in some member variable of the repository typically. And that follows the same rules that it should be restored automatically on resuming from termination. So what it does is it takes a dependency on this session state service. And when it does its reads and writes, basically the session state service, as I mentioned, just exposes a dictionary. So you read and write key value pairs into that dictionary. And when it sees that the app is suspending, it'll persist it. When it sees that the app is launching from termination, it will repopulate that for you. So you just use that as your kind of buffering mechanism for any of this transient state that you want to make sure automatically resumes for you. And the way that gets injected is up at the app level. It's one of these things in the initialize here. You can see that we new up our repository and pass in the singleton that is created by the application base class for us. So you do have to do some dependency injection to wire up all these layers and stuff and have these shared services, but you can do it the way this app's showing it through manual dependency injection, or a kind of smarter way in the big scheme of things is to use a container, which, as I mentioned, the Adventure Workshopper does that and the other Hello World does that. But I didn't want to have to get into containers here. All right, the navigation part of it's pretty straightforward in this case. Over in our main page view model, when we clicked on that button, we had a command. Using the delegate command is one of the features, again, of Prism, this command that you can easily expose as properties from your view models and bind to it from things like buttons. And you can see the handler for that is up here. It's just saying that we inject the singleton navigation service from our application registration, and then we make a navigate call with a page token again. And it's, again, going to tack on page to whatever new name we give it there, look in the view subfolder, new that thing up, and navigate to that page. Okay, so that's the basics of navigation and state management. Any questions on that so far? All right, I will take questions at the end as well. Okay, the last thing I want to cover here, how are we doing on time? Okay, still got 20 minutes, good. Last thing I want to cover here is the validation mechanisms we put in place. As I mentioned, the bad thing, or not bad thing, it's a version 1. You got to give them time for certain things. One thing that's kind of missing right now in WinRT is that we don't have built-in validation support at a UI level the way WPF and Silverlight did. So there's no knowledge of validation in the bindings as WPF and Silverlight had, and there's no control rendering for an invalid state, which both WPF and Silverlight had. So basically, you either need to build your own, or the good news is Prism has kind of done it for you. And the things you would want that validation to do is, as I showed during the AdventureWorks demo, is, first off, don't annoy the user if they haven't done anything wrong. So defer validation until they've actually put some input, which kind of ties in with one of the later bullets, which says, wait until a property changes as your trigger mechanism to say, when should I do validation? We wanted to do it in a way that's fairly standardized as to how you define rules. If you haven't been exposed to data annotations yet, you probably haven't been looking at many .NET technologies because most of them are starting to flock that way. ASP.NET uses it, Entity Framework uses it, Silverlight used it, WCF RIA services used it. It's becoming pretty common, and it's basically a declarative attribute-based way of expressing simple validation rules on properties. And I'll show it in a demo here. So we want to, obviously support that most common way of doing validation. Now, this is another one of those things, similar to the question in the back there. I wish we had put a easy hook here to say, call my validation rules. We don't have that. So it's one of those things that if you want to use, say, there's something out there called Fluent Validation I've used with a customer that's kind of slick on Codeplex. If you want to use something like Fluent Validation instead of data annotations, you'll have to go modify the code. But the code's all there for you to do that. That's why we put it out there that way. We wanted to support, having your rules defined at a view model or model level, although mostly we expect it to be on model objects. and we need some way to display those errors to the user when a validation rule is triggered. So what we've got in terms of Prism support is a set of classes that provide the underlying infrastructure for evaluating rules and storing the errors associated with the property. So there's a class called Bindable Validator, manages that errors collection. It's really, a glorified wrapper around a dictionary of string and list of string when it comes down to it. So the idea is that for a single property, you may have multiple rules, and more than one of those rules may be an error. So you need a list of error strings for each property in a given object. And so it manages this error collection. It also is where the code that evaluates those data annotations exists, and it's going to be triggered by a call to it that says validate property. Then to tie it in with your model objects or view model objects, there's a validatable bindable base. So kind of a long word to say there, but basically it contains one of these bindable validators. It makes those calls to validate property when a property change occurs on the derived object, basically. So the idea is you will inherit from validatable bindable base on your model objects. You'll expose properties that are the things that are being set. When those get set, you'll follow the patterns of bindable base, which this inherits from, which again is one of those stock classes in a Windows Store application. We've got a copy of it basically down in the Prism libraries so that we can take a dependency on it, because normally that's not injected into your project until you create a project in Visual Studio. But we needed to depend on it for this mechanism. So Prism has its own bindable base. It's almost identical in code to the one that gets injected by Visual Studio. Validatable bindable base inherits from that, monitors the property changes. Actually, it gets triggered from the set property block in it, and then it calls into the bindable validator to trigger the validation. And then it also exposes the errors collection that is exposed by the bindable validator for binding purposes. And then finally, you need a way to show it. So this part is not down in the reusable libraries, because the way we implemented it, both in the quick start I'll be showing and in the AdventureWorks shopper, is to make the way you go about displaying things more stylable, to use styles within XAML. And so that means the styles have to reside within the resources of the application, which makes it kind of hard to put into the reusable libraries. You could hard code this down into a behavior and put it in a more reusable form, but then it can't be overridden with styles, which is not a great thing itself. So let's take a look at how this all works. So I'm going to go down. It's a separate quick start here is a good starting point for this. Again, you saw that there's a lot of validation in the entry fields of the AdventureWorks shopper, but to really just focus on these mechanisms I'm talking about, this is a great starting point. So we take our dependency on the store apps library where those base classes I just talked about exist. And a good starting point is to look at, what's the data object that we're going to be binding to. So for this simple example, actually a better part is visualize what the hell we're talking about. So in this quick start, we've just got 3 simple input fields, first name, middle name, last name. Similar to what I showed in the AdventureWorks demo, the idea is, no errors in the user's face initially, but as soon as they've changed something and made it wrong, and these are required fields, then we want to, A, highlight the control. So we're doing the default boxing in this case, and we want to show the errors to the user somewhere on the screen. The showing of the errors is really simple data binding when it comes down to it. As I just mentioned in the slides, ultimately that base class is exposing an errors collection, and you just need to bind to those collections from a text block or whatever presentation element you want to use to display a string somewhere on the screen. So this is just actually a items control down below the validate button that has a template associated with it that puts out text blocks for each error. But you saw in the AdventureWorks shopper one, we actually put it next to each field, the individual errors for the field. And in that case, we were only displaying the first error for the field, not all of the errors that might be there. So, the exact mechanism you want to present your things, we didn't try to constrain you on that. We'd more just show you a technique for how you go about displaying them. Okay, so let me, and the other thing here is, if you press validate, or submit, or save, or something like that on the screen that's intended to be a final action on the aggregate of all those fields, then you obviously want to evaluate everything. So in this case, they all box red, and all their messages show up at that point. Okay, so what we've got here, again, from a code perspective, is we've got the model object that's being bound to. You can see it inherits from validatable bindable base, which I'll drill down into in a moment. And then it's just using data annotation attributes here to express the rules. If you haven't been exposed to those, you've got several built-in ones. You've got required regular expression, which is pretty darn powerful on its own if you can just figure out the crazy, comic characters to put in there to come up with the regular expression. You've got a range validator for numeric input. You've got a string length validator. And then the ultimate hook is you've got a custom validator that you can point to a method that you implement that you can do cross-property validation, whole cross-object graph kind of validation if you want from a method that you write. So you can achieve just about any kind of validation on your objects with this mechanism. So we declare what are the rules on our object. Because we inherit from validatable bindable base, if we drill down, like I mentioned in the slides, it contains a bindable validator. So we'll drill down to that, and you can see that it exposes a errors collection somewhere down here, which is ultimately the ones that have been evaluated and put into this collection. A property name as a key, and then a collection of strings as the errors associated with it, which will just be an empty collection by default. And each time it evaluates it, it clears it out and repopulates it. And then further down, you can see there is a validate property that I mentioned that's going to be called by the thing that's containing it. Whenever your trigger occurs, it says go ahead and evaluate this property. And it's going to go through and do some reflection type stuff, but the important part is down here with this try-validate property call. And it's using the validation context and the validator classes from data annotations. It's a standard couple line of code pattern where you basically say, get a validation context for the object I'm working with, and then call the validator class to basically trigger it to go reflect on that object, find the property that you're validating, find the attributes on that property that you're validating, evaluate those attributes and their underlying rules, and then get back the error messages if there are any, and it puts it into its errors collection. So that's all down in the bindable validator. And then the bindable base here, the validatable bindable base, that's a lot of syllables. Basically, it just exposes that errors collection from the bindable validator. And it triggers further down here, because it also derives from bindable base further down. It has this set property method, standard pattern in Windows Store apps you'll probably been exposed to. But it's just a simpler way to declare your set blocks instead of always, well, let's just drill down to it real quick. I got time. If you drill down to bindable base, instead of the normal implementation pattern of I notify property change is in every one of your set blocks, you have to check, is the value being set the same as the current value? If so, I do nothing. If not, then I need to raise the property change event. So just to encapsulate that pattern, bindable base has this set property method that does the checking for you, doesn't do anything if it's the same, and does the raising of the property change through a separate helper method down here that does the property change. So just an encapsulation of that so that your model objects can have these simpler set blocks that just look like this, just making the objects themselves a little more clean. But as a result of that, the validatable bindable base, let's call them Bob and Fred, that'll be easier. Bob here overrides set property, and you can see it's using it as a trigger point to evaluate validation through that bindable validator. So that's the underlying mechanisms to get the rules in place and get the errors in place. Now we need a way to display them. So up in our view, go up here and rearrange things a bit. And we can see there's some text boxes and text blocks. We just have a standard binding down into or exposing a user info object from our view model, and then we dot down through that to the individual properties here. And then we've got what's called an attached behavior here. So another attached property, really, that has some behavior built into it every time it's set. It's expecting you to set it through a binding that basically points to the errors associated with the corresponding property. So you can see that because that errors collection is exposed from the base class, and I didn't show it in the base class there, but there's an indexer on that errors collection on the base class. So you basically go down to the errors collection, and then you can index in with the name of the property that this thing is binding to. And that's just going to get back the list of strings, effectively, really a read-only collection of strings associated with that one property name. And then it basically can do whatever it wants. The implementation of this one is here within the quick start. And what it's going to do is, first off, you can see the attached property declaration up above with the change handler that gets called every time it's set. The change handler is down below, and it basically says, okay, first off, it's hardwired to a text box. It's one of the limitations of the WinRT platform right now. How many people in here have used blend behaviors in WPF or Silverlight? A few of you. Okay, so blend behaviors are nice because you can hook them up to any control, any event on any control, any property change on any control, and use that as a trigger to go do things. We don't really have the raw mechanisms to do that yet in WinRT. So you actually have to write these kind of one at a time as attached behaviors, coupling them to at least a base class of a control. You could write one, for example, against framework element for setting a style. This one, we just wrote it directly against text block. But ultimately, you can see what it's doing here is it's going to that thing that it's bound to, which is a collection of errors, seeing if there's more than one or more there. And if so, it goes out and reaches out to the surrounding application, tries to locate a named style, and apply that style to the text box. Conceptually, all this is doing, if we go find that style, is it's setting the border color to red. So if we look here in the XAML, where that style gets defined, it's setting the border brush to red. And that's where the red boxing comes from. But if you want to round the corners or pop up a tooltip or whatever you want to do, you can do that through that style. Now, you could also hard code this down into the behavior. If you go look at some of the resources, I'll point to the end in my Pluralsight course, and I've got an article series. I showed an example where I hard code down into the behavior setting the border brush. What's the problem with that? Now you've got programmatic code that's going to override styles. If you've got a designer that comes in and says, no, I want green borders, they're going to get a little angry when they show up red. So, hard coding it down into the behavior is not a great thing to do. That's why we went ahead and showed it as driving from your resource styles here. But that's basically how the red boxing happens. How the actual error text shows up is basic data binding, as I mentioned. Down below here, we've got an items control. We've got a data template for it with a text block, and it's binding to whatever the current item is, and we're binding it to a separate property exposed from that base class called all errors. So it's not on a specific property with the indexer, it just aggregates them all into a list.
So is that, for the button where it says command equals binding validate command, is that what actually wires it up so that when you hit that button?
Yeah, good point. So let me show that as well. When you want to trigger evaluating all your property errors, down here we've got our validate. We've got a separate method we can call on the base class called validate properties, and that triggers it to go validate all of them at once. Okay, so those are the basic mechanisms there for doing validation. It's pretty straightforward and easy to use and reusable in your things. Again, all the infrastructure for your model objects and the collection of the rules and the errors and all that is in the reusable libraries. The behaviors, you can pull this one out of the quick start, or there's two separate ones in the AdventureWorks that you can pull out as examples of how to write those behaviors. All right, with that, let me go ahead and finish up here. There's a couple other things I don't have time to go into here that are in Prism. The web API stuff, if you haven't worked with web APIs, an alternative to WCF SOAP-based services, we chose to use those because especially if you're building a Windows Store app with the intention of putting it on a Windows tablet, there's a very good chance, Microsoft people, close your ears, you might actually want to put it on those other tablets as well, those iOS and Android devices. So web APIs are a lot easier to consume from those than WCF services. So we chose web APIs. We show both kind of CRUD style calls and RPC style calls in there, how to call them with HTTP client from the client side, also some simple implementation on the server side. We do security with forms-based authentication. Most people are used to thinking of forms-based authentication is only applicable to web applications. Really, it boils down to round-tripping a cookie, and it's very easy to do that through an HTTP client. So we demonstrate how you would do that. We also demonstrate, as I showed with the demo of the zip code, server-side validation. I don't have time to go into the code for that, but ultimately what we're doing is we are using model binding on the ASP.NET side, using MVC model binding on the parameters that come in to evaluate those same data annotation attributes or even custom rules in the methods that get called. And then we return the model errors using MVC, which basically serializes out, surprise, surprise, a dictionary of string, comma, list of string. So it's basically already in the structure that we want it on the client side. We just have to deserialize it and reaffiliate it with our properties on the client side. Platform features that we demonstrate mostly in the AdventureWorks shopper there is search charm, but if you go down in the reusable libraries, we've got a wrapper around how you invoke the search charm so that you can do that from your view models in a testable way. We've got the settings charm, similar thing, kind of all wrapped up so you can do it, control it from your view models. We've got the way you can pop out, fly out panels wrapped up as a service as well. Live tiles, we show both, the basics, which is pretty straightforward in the SDK on its own of how to, create your own live tile, but we also show how to create a secondary tile, which lets you navigate and gives you basically deep navigation to a particular view within your app, which needs to get dispatched all the way down as a navigation call to a particular view and view model. And then the persistence, we have a local caching. We pull down all the product details for the products that you're seeing on screen, and we do some local caching through local storage there that you can check out as well. Also, credential management, I mentioned the password vault. When you check that box to save credentials, we've got that wrapped up in the service called the account service in the AdventureWorks shopper, so you can see how to work with password vault as well. Okay, a couple of things to back this up. As I said, my Pluralsight course, if you can't grab a card here because I ran out, go to the Pluralsight booth. You can go watch that course and many others for free, as many as you can jam into a month of your time, or just subscribe and then you got an endless supply there. And then I've got an article series on the site called The Silverlight Show, which has more than just Silverlight as a dying breed there. I've got an article series out there. I haven't done the validation one yet. That's due out in a week or so. So you'll have to wait a little bit to see the background info on the validation there. But I'll continue that on with a few more articles as well. There's already, I think, 4 in the series. So with that, please do fill out your evals. There are other resources out there. There's another session you might want to check out tomorrow. I mentioned my navigation one at 8:30 tomorrow. There's one by Robert Greene tomorrow at 5 o'clock talking about the design concepts of how do you morph a traditional line of business app with hundreds of screens and pop-up dialogues and data grids everywhere. How do you deal with that in a Windows Store app that's all square tiles? So that's another good session to check out as well. So please fill out your evals, enjoy the rest of the conference, and I'll stick around for questions. I'll also head down to the TLC at 10:45 to 12:30. I'll be at the Windows 8 development booth down there if you want extended questions. Thank you. The design. What title of your talk is design? Design guidance for Windows Store line of business apps tomorrow at 5 o'clock.